So we're half there?
It's a good question. Getting close.
Thank you for coming. Just a couple little tidbits before we start. I had to go to Egypt to get help. So some of you know Ahmed from a couple of years ago. He went to school here, and his fiancée is with us, Miriam. If you have any techie questions on AI, ask her. If you have anything on, okay, fill me in. A neurosurgeon, ask him. And he learned all of that, and he lived here and went to school here in Lansing. You got that? So, with that, welcome. My name's Burke. I'm the director here at the library in Lansing, and like we said, we're going to past the 2 years. Marianne Baldwin is videoing. This will be on YouTube, so we don't pick it up tonight, and we are live streaming. If the expert here can do it, are we on?
Yep.
Okay, thank you. And with that, Clayton Burke, no relation, although it wouldn't be too bad. Do we look alike? But thanks for coming, and I'll leave it with Clayton. And where's your crew?
All right. Well, we got one hiding out in the audience. Not sure where the rest of them are, but probably busy working on the bridge.
Well, yeah, you got to get it done.
Yep, we're working on it.
Full time. Okay, with that, thank you. Enjoy the evening.
All right. Thanks, Derva. Got another great crowd here tonight. Lots of familiar faces. If you're not familiar with me, I am Clayton Burke, the Iowa DOT project manager for the bridge replacement project here in Lansing. And once a month we get together and we do these bridge talks. So I'm going to go through and give you a little update on some of the construction that's been happening on the new bridge. We've been working on Pier 1 and 2, the approach bridge deck, the west abutment, and we're also getting ready to start setting steel for the new truss, which is a very exciting milestone for us. And then we've got a special surprise afterwards. Is that all set up, Travis? Oh. We'll have a special surprise later. Is that all?
I don't see it.
I don't see it either. Maybe. Otherwise, Travis has something really cool to show you up on the wall. So, diving into it, we've been working on Pier 2 out in the middle of the river for quite a while now, and I believe the last time we talked we had poured the lower portion of the pier columns, what we call the saddle, and now we've been working on the middle of the columns and the cap of the pier. And right here you can see all of the formwork, the thermal blankets that cover the formwork, the cooling tubes, because again this is mass concrete, so we care a lot about the temperature inside the concrete, the inside compared to the outside. So we don't want the inside to get too much hotter than the outside, and that's why we pump cool water through the concrete on the inside to cool that core, and then we put thermal blankets on the outside to heat up the outside. And that's all to keep the concrete the same temperature as it cures. And that prevents cracking primarily. So we've got the blankets, the cooling tubes, and then inevitably the contractor pours the pier. They pour the concrete in there. I believe it was around 530 cubic yards of concrete. And that was, to get it out to the middle of the river, they have to use 2 concrete pumps, which is pretty unusual. So they dump the concrete into one pump. That pump pushes it all the way through the hose into another pump, and then that one finally pushes it out into the middle of the river. And then they take all the forms off after it cures, and the temperature has gotten close enough to the outside temperature that we're not concerned with cracking. And this is what it looks like. So this is now the completed Pier 2 out in the middle of the river. You can see kind of the patchwork from the forms, which will age with time, and we may clean some of that up to get a more uniform look. But this is ultimately kind of what it looks like, those large concrete structures. After you take those metal forms off, you have a nice finished product like this. And then on Pier 1, we are working essentially on an identical pier, and it's using the same formwork. So after they finished taking the forms off of Pier 2, they were able to start using those forms on Pier 1. And to start with, of course, you have the rebar that reinforces the concrete, the columns, the saddle, the cap. This rebar is protruding out of the footing, so that's why it looks like it connects to the concrete. It's actually sticking down into that footing and creating a strong bond between the footing and the columns of that pier. And then you can see it kind of swoops off down into the saddle. That makes that nice open window in the middle of the pier. And then the contractor will bring in those steel forms again and set them up around the rebar. So after we finished the saddle and the lower columns, we again put the steel forms up for the column and the pier cap. And so you can see this is Pier 1 right on the Iowa bank. It's very tall and very close to Front Street. You're also working over the railroad here. So everything has to be done with lifts and extending over the roadway. It adds an extra layer of challenge to the process because you have to move if a train's coming. So they constantly have to get up there, get some work done, move out of the way for a train, get back, get some work done. And there is a railroad employee called a railroad flagger that works with us on site. And that railroad flagger keeps track of all the trains and keeps track of all of the employees and people working in the work zone, and then alerts everybody when that train is coming. So they get about 15-minute warning. You've got to get out of the way and be ready for that train to come through. So here, again, mass concrete because it's very thick, wide, and tall. There's the cooling tubes getting ready. And then we're going to pour this with another set of 2 pump trucks. This time it's not out on the water a long distance, but we have to pump the concrete underneath the bridge and then up over into the pier forms. And then again, you have the train element that complicates it. So this was again another 530 cubic yard pour, which takes most of the day. So naturally you'll have several trains come through while you're pouring concrete. And you just have to stop, swing out of the way, wait for the train to come through, and then go back at what you were doing. And then after it cures and the temperature is all good, this is what it looks like with the forms taken off. So now we've got the west abutment complete, we've got Pier 1 complete, Pier 2, and the remaining piers on the Wisconsin side. So it's kind of a big milestone again to have all the substructure concrete poured. So we're very excited about that and getting to move on to the structural steel. Last time we were starting to touch on the Wisconsin bridge approach, the approach bridge, and the concrete deck that we poured on it. So here you can see, if you've driven over the bridge recently, you can see that nice big deck spanning along the side of the existing bridge. This is providing a 40-foot wide roadway between the barriers compared to the 21-foot wide roadway on the existing bridge. So the new roadway will be much wider. You'll have full 12-foot lanes with 8-foot shoulders on each side. So quite a bit more space for users, commercial vehicles, everybody to get through that bridge. Here, kind of an interesting point. So to go through what equipment you see, all of these yellow trusses or this yellow steel frame that you see, that's all part of the paver, what we call the paver or the brand name is a Bidwell, and a lot of people like to call it by the brand name of Bidwell. So this Bidwell has a track on it, and then a device or a section underneath that track that goes back and forth. And that track follows the crown of the roadway. And again, the roadway isn't perfectly flat. We have what we call a crown in it. So there's slope on each side of the middle of the road, and that lets water drain away from the center. So this paver is actually set up to not be perfectly flat, but it's set up with that crown in the middle. And it goes back and forth and back and forth. And you have people working in front of it that move the concrete into the right place and shovel it so that the augers and everything spread the concrete out just right. And then behind it, you get this nice smooth surface. But we don't want a nice smooth surface to, per se. We want a surface that's a little rough for friction so that your car tire grips it really well. And that's why you'll have... I don't think you can see it in this picture, but you'll have somebody with just what we call a broom, which is just a broom, and you run the broom across and pull it back, and it creates that nice texture on the surface of the concrete so that your cars will have a nice grip and you won't be slipping around on a wet, slippery bridge. The next step is to put this brown stuff down. It's burlap. So they're long sheets of burlap. We get them wet before the concrete is placed, and then we put down the wet burlap on top of the concrete as close to the paver as we can to make sure that that concrete stays wet as it cures. Because a very important aspect of concrete is the water to cement ratio, and that when you have the surface of the concrete here facing the sun and the air and the wind, what happens is the water will dry out from the surface, and that can create shrinkage cracks or other defects in the concrete that we don't want. So we want to keep that surface wet so that it has enough water to hydrate and stay nice and strong. And then you put burlap on the entire bridge, and then you set up a system of sprinklers. So that's how important that wet cure is, to have the water on the surface of the concrete for 7 days after you pour it. So they'll keep those sprinklers running. They have pumps down in the river that pump the water all the way up here, and then they run all the way along the length of the bridge deck. And then after the 7 days and the burlap has dried out, the contractor will pull it off, and then you have the bridge deck. And here you can see that texture I was talking about. So it's nice and rough across the deck, and then there is a section on the very edge that they don't broom. And so the water will run off and hit the smooth spot and go down to these drains that are in the bridge deck. And so this is an entire system designed to get the water off quickly and efficiently so that you don't hydroplane or have any issues with icing. And then moving on to the west abutment, this is the location where the new bridge will touch down on the Iowa side. Here you can see 2nd Street is just behind this. We've talked about the retaining wall before, so this is what we call a mechanically stabilized earth wall. It's just a bunch of concrete panels that have metal straps that go back, and then we fill the back with sand, and as we fill it up, we put the straps out, and then we bury those straps with sand, and that holds those panels in place. So that's where a lot of the strength comes from. So we've built this up. We poured coping, it's what we call coping on the top, and that just covers the top and bonds the top of the wall together. So that's just concrete that we poured in place. We have the abutment concrete here behind this framework, and that is all complete. So, in this picture, we still have the top to pour. I think we've got another one here. Oh, that's ready to go. Yep. So that's ready for steel. Here you can see some large steel tie rods. And they're just threaded rods with large nuts on top. And it's kind of a unique feature of this bridge. When the steel is put together, there's going to be a point in time where it's, and I think we've got a good picture of this coming up, but the truss will sit out over Pier 1 and hang out over the river. And when it's hanging out over the river, it's going to want to teeter-totter over Pier 1. And so these tie-downs are actually going to hold the steel truss down rather than push up on it. So it'll be lifting up on this side and hanging out over the river. We're also, so I mentioned, we're at an exciting point. We're getting ready to start setting steel. And so if you've been along 2nd Street recently, we've had this blue crane sitting there supporting the construction of the abutment. And then it's also there to help put together a brand new 300-ton crane that Kramer just bought. So quite the excitement the last couple nights out on 2nd Street. We had to close Iowa 26 and the Iowa 9 crossing to have enough room. So this comes in quite a few different truckloads. So the crane doesn't just drive up on a trailer and get delivered. The tracks come in one load, the body comes in a load, the different components come in a different load, the weights, and so on. So this,
17 trucks.
That was 17 trucks to get that out there. And that was just the first night, right?
Well, that's the whole.
Or that was with the boom too?
Yeah,
Okay, 17 trucks total. And then you need another crane to put it together. So there's the crane that builds the bridge.
Theoretically, that crane is self-assembling, but it's just easier to have another crane.
Yeah. So if you've driven by today, here's the assembly at night. Right here you can see them lifting a counterweight onto the back of the crane. And the second night we brought in this boom and put, Travis, do you remember, is that 200 some foot boom?
265 foot, I think is what they're
265. So quite a tall boom, massive crane, something you don't get to see on every bridge project. So we're pretty excited to have this here in town. And that will get us ready to start setting steel beams off of this abutment. And to do that, we have to construct what we call shoring towers.
Keep back up a second.
Yeah.
So this crane is what they call a VPC crane, variable position counterweight. So in that right-hand photo, that big stack of counterweights there, there's actually a tray that slides on. So as you start picking up a heavier load, that counterweight will slide back. There's hydraulic systems that push that counterweight back to counter the load that's being picked up with the crane. So this is a very sophisticated piece of equipment.
Yeah.
To for heavy picks.
Yeah. Did Kramer tell us how much that cost?
No, undisclosed, but it's probably somewhere between 2.5 to 3 million, depending on
Yeah.
what sort of doodads are all on there.
Yeah.
Technical term, huh?
The doodads.
Does that boom telescope? That boom does not telescope. This is the last boom crane, so those are fixed lengths, but you can add boom or take boom out depending on how much reach you need and how much you're trying to pick.
Yep.
Then you can put over 350 feet of boom on that crane, but then of course your capacity is a lot less.
Yep.
This is the third job where we've had this similar crane, a 300 VPC on it. So they're a really good outfit.
Yeah, thanks, Travis. Yeah, the very interesting crane. And then we'll get to, like I said, setting steel. So to set that steel on something, because we don't just have 400 foot pieces of steel, we have little 50, 60 foot pieces of steel, and they go together. So to start with, we have to set them on top of shoring towers. And those are just temporary steel towers that will support the bridge while it's built. And then once the bridge can sustain its own weight, when all the different pieces of the truss are put together, then those shoring towers get taken away and it holds itself up. But to do that, on the Iowa side, we're mostly supporting them by pads. So here you can see on Front Street, underneath the existing bridge, they are setting up and pouring large concrete pads. And those concrete pads will support these steel towers, and they are currently. So they have, I don't know if they're completely done with the 2.75 shoring towers, but these ones here are set up. They're up by the abutment, and you can see these are sitting on wood pallets, we call them crane mats, and they're just big bundles of like railroad ties, similar material. And they're pretty universal. They use them for many, many different things, but in this case, we're using them as a foundation for those shoring towers. And kind of an interesting point about these, you have these tiny little boxes on the bottom that everything sits on, and we call those sand jacks. And what they allow us to do is they will set this tower to a very specific elevation. They'll set the steel on top of it, and then to get that tower back out with the steel on top of it, you have to relieve that weight and that height of the tower. So they will open up little ports on these sand jacks, so they have little holes in the sides that have bolts that are filling them. You take the bolts out and you blow sand or water into you blow air or water into those ports, and the sand comes out one side, and then the tower slowly lowers. So that's how the contractor will get these towers back out after the steel's put on top. And yep, here's what Front Street looks like after the concrete pad is poured, and you have the crane mats underneath. So they're getting these done. Unfortunately, Front Street will be blocked off for quite some time while we build the new bridge, as well as take the existing bridge down. But after they're done, they'll take these pads back out, clean everything up, and restore Front Street to the original condition it was in. So if there's any damage, we'll fix that. And then you'll have a nice new bridge over it. And then, kind of an interesting part of this, typically the railroad doesn't let you very close, but we were able to get approval to build these shoring towers just right next to the tracks. So those trains come in and they're very close to those shoring towers. And so to look at kind of what the setting of the steel will look like, we've got a diagram here that shows these are the shoring towers that we were just looking at. This red box is the train. This is the train track and train that comes through. This is Pier 1 on the Iowa side of the river. And then what we're going to do is we'll remember these these sections of steel come in pieces. They don't just go from the abutment to the pier. So we're going to start by setting the steel from the abutment to this first shoring tower. And then we'll get that stabilized with the rest of the pieces of steel that make up the truss at that point. And then we'll just keep working our way out to the next set of shoring towers, connect everything, stabilize it, and then reach from this shoring tower out to Pier 1. And at that point, you won't have any of this part. You'll just have this vertical piece to the west, and that'll be the first section of the truss. And then after they have that built, you can start building what we call a cantilever, and that just means that it's a structure that hangs out without any support. So this is entirely supported by this first section of the truss. So this, if you imagine that weight hanging out there, this truss is pulling up on that weight and holding it in place. And that's why the weight over here is going to pull up on this abutment, and that's why those tie downs are so important. So they'll come off of Pier 1 and build out over the river, and then we will essentially move to the Wisconsin side after that, build the Wisconsin side, and then the very final piece, we're building the center of the truss either next to the marina or next to the existing bridge. We're not entirely sure yet. We're talking about different options, but they'll build the center section on a barge and actually float that barge over here into place, and then they'll lift that center section up with what we call strand jacks, which are just cables with these massive jacks that very slowly pull the cables up, and they'll lift that entire section into place, bolt it in, and then it'll be set. There's a few other steps after that for establishing continuity and different components, but primarily you put that in place and then you have your continuous truss.
What's the time frame to get to Pier 1?
To get to Pier 1, is it December? Okay. And then did they say anything about the rest of the truss?
Well, they
Or-
usually by end of January, right?
Yeah. So this coming the middle end of the winter, we should have the rest of this in place. And spring, they're moving over to the Wisconsin side. February, yeah, February-ish.
Is that about a third the length of the whole bridge? What's on the
It'd be a little bit more. The center section's very short compared to the rest of it, right?
Well, there's 25 bays, right?
Yeah.
So we got 8 bays here.
Yep.
And the bays in the main span are slightly larger than the bays in the back span. So we got about a third.
So, but yeah, it's all coming together. We're getting the cranes in place. The steel is being fabricated and shipped from Gary, Indiana, out of this massive steel factory. It comes with that really nice coating that has the 3 different parts: the metallizing, the epoxy, and the urethane, that should help it last for a very long time. And then we will keep moving with the bridge. So any questions on the progress we're making so far?
Are the curbs on the Wisconsin side poured?
The curbs?
The curb, the floor, the approach is poured.
Oh, no. So we just have the bridge deck down. We don't have the concrete barrier rail that will go next to the deck yet. That'll be coming in probably this fall. It's not a priority item right now, but it does need to get done at some point before the rest of the bridge is built. So, kind of an interesting point on that. So the concrete barrier will be a little different on the new bridge. So typically we just have a tall concrete barrier, and that's it. It's just the concrete, and that's the barrier. In this case, we have a shorter concrete barrier, so what we call a 2-foot parapet. It's just 2 foot tall, and then we're putting a steel railing on top of it. So that'll make it more open, and you can see more out of the side of the bridge. So, and it'll, I think, look pretty nice compared to just some plain concrete out there.
Is it pedestrian friendly?
Yes, it does meet the requirements for pedestrian traffic and bicyclists. So it is technically just a shoulder, but
Will there be a line? Like
there'll be an edge line painted on the roadway. Yep. So a lot safer than riding your bike down the middle of the existing bridge.
have you ever?
I haven't. I don't know if I could.
You don't like
Yep. Yeah, in the back, sir.
That pause that you're doing when you're pouring the concrete on the island side due to the train,
Yep.
does that affect the integrity of the concrete since it's not continuous pour?
If they can pour it at a fast enough rate, so that pause is, what do you say, Travis, 10, 15 minutes at most? As long as they can get right back into the top of the formwork and they can place that concrete in the right pattern, so they're not putting it all on one side and then letting that get hard, we don't have any issues with we won't have any cold joints or any integrity issues with the concrete. So If it was longer, like a 45-minute pause, then we'd have more problems. But we are able to keep it down to a smaller window. No, that's a great question.
An additional question, how
Yeah.
do you monitor the temperature of the concrete?
So they have digital sensors that are placed at strategic locations throughout the concrete. They are typically tied to the rebar, that metal cage inside, and then there are some that are close to the surface of the concrete and some that are in the very center of the concrete, and then we compare the difference between those two. Yep, they'll be in the concrete forever. So, and the contractor has a fancy device that reads all of them, and is it command center?
They're wireless
Yeah.
recording, but they're wired sensors.
So they communicate wirelessly, and then we see that on a dashboard on a website, pretty much.
Any reason to monitor that over time?
Not after the concrete cures. It'll just be a nice, stable line, and there's not much that can happen after it's all set. Yeah.
What is the length of time for the cure?
What we're seeing for that thermal, what we call the thermal control period, is about 7 days, so about a week. It takes for the concrete to stay within that close tolerance between inside and outside, and then the whole system has to get within 50 degrees of the outside temperature, of the average ambient temperature. And then after you get to that point, there's no more cracking concern, and they take all the blankets and forms off of the concrete.
Is it another month or 6 weeks before the internal and exterior temperature are the same?
That's kind of a deep subject we could get into on the curing time of concrete, and typically it takes 28 days to get to 95% strength, but concrete is almost continually curing, like is the Hoover Dam still technically
It's still technically
curing? Yeah. And that's because it's so massive. But there would be a certain time period where it takes for the outside to reach the inside temperature and match the ambient temperature. Yeah. Yeah, Bruce.
I wondered a little bit about how in the world how do you operate a budget for a project like this? Because I'm thinking, okay, so you pick a number,
Yep.
but from what we've learned here, there's always things that crop up. And so what? So you have a budget. What is it now? Like it's around 140 million, but it does. The cost just increases based on the things that weren't anticipated.
Right.
And then, but where do you get that money from?
So you're asking the tough questions, Bruce. But to get to it's very complicated, but kind of the simple version is during the development process, we come up with a figure that we call the engineer's estimate. And so the engineer will come up with quantities and prices for those quantities. So you have so many cubic yards of concrete. Based on other projects, that concrete costs somewhere about $1,100 per cubic yard. And they'll use that to come up with a total estimate for the project. And then they use that estimate for budgeting and programming, and they'll take that number, and in this case, we're actually working with Wisconsin as well. So we have an agreement with Wisconsin that has a set budget in that agreement. And we took that number, and then we add contingency to that number. So 10, 15%, you put that extra in there and you hold those funds because you know on a typical construction project, your design bid build process isn't, if you don't spend an infinite amount of money and an infinite amount of time designing it, there's something you're going to miss. You can't spend enough money to get a perfect design. So the expectation is that there's going to be something unexpected, there's going to be something unanticipated that's missing in the design, and you're going to have extra costs. And typically what we see is that 10 to 20% range. So we add that as contingency in our agreements with other states. And then we have a line item in the DOT budget that holds funds for construction projects across the state. And that's, I think, around 10% of the program. And so they have that funding available, and then projects that have these extra costs that come up will draw from those funds as they come up. And if we get close to the running out, then they have some financial managers that are way above my head that adjust things and make sure that those extra funds are there when they're needed. Did that answer your question, Bruce?
One of the points is there's always funds available one way or another.
Right. Because you could run into,
There's funds available as long as you stay within that expenditure group. You have a cost, here's the bridge, and then you can plan for extra expenditures. If you go over that, it's my experience that you have to have additional approval and have some things to answer before you get that additional money.
right, it's a little different at the state level. So they have the entire program and a program line item for extra work orders. And so at the construction engineer level, there are processes in place for those extra work orders to get reviewed. And so every expense is reviewed by another level of engineer. So that it's not like we ever just approve expenses and pull out those funds out of that line item.
And my point is you have a certain
Yeah.
amount, here's what we thought it is, and you have some variability that can go into there. If you
Yep.
go over the variability, then there's a lot of extra steps that you have to go through. Now, that's been my experience.
Yeah, in this case, it's more a review-based process. There's no set limit. Every single extra work order has to be reviewed and approved. You can't just, and that's where it gets into the line item. So there's a massive line item for every construction project in the state. And then the financial managers within the state government adjust that line item as needed to make sure that there's enough funds to cover those extra work orders. But there are many blankets of security that go into that. So if I write an extra work order for this project, it has to be approved by the district construction engineer in Mason City. Federal Highway typically has to look at it. Wisconsin looks at it. And so there's many different reviews that go into every single one of those work orders. And then if it's over a certain value, so if it's over $150,000, then it goes through another set of reviews from our central staff in Ames, and they have to approve it. And so again, I don't want anybody to get the idea that they're just spending without oversight. There's a lot of oversight that goes into it, but at the state level, we don't have individual targets for projects. There's no set limit for an individual project. It's just managed as a global budget, essentially. I'm not the financial expert, so I'm trying to make sense of this, but
What percentage of the cost is federal versus state?
this project, it's 80% federal. Yep. So, and that's a whole nother subject, getting into federal funding, and it's the more you use it, it's not like you get more federal dollars. If you use more federal funds on this project, you don't have to use as many on a future project to meet the amount of funds that they give you every year.
So are there manuals on all this? I mean, how in the world, like, it just seems so complex.
Yes, there are very long and lengthy manuals that I've
I would imagine it, yeah.
worked with for the last 13 years, so they're
What you dream about?
some dates, yeah. Unfortunately. Yeah, just sections of code and specifications and all that fun stuff.
Thank you.
No? Good question, Bruce. Any other questions about the bridge or anything else?
Are you going to address anything around the ferry?
Yeah, car ferry.
I was wondering if that would come up. So what we are communicating is that we're working on the car ferry actively, and it's a priority of ours, so we're putting a lot of resources towards getting this car ferry set up. We can't say publicly yet that it's a guarantee because we still don't have the environmental permits, and we don't have a contract signed with a provider for the ferry service. But I can say those things are getting very close. We're making progress every day. We have meetings after meetings after meetings with all the different stakeholders, the DNR, the Fish and Wildlife Service, the Army Corps. All of these agencies play a massive role in reviewing our plan for this ferry and making sure that we're not overlooking an environmental impact or a flooding impact. The Corps cares a lot about, if you put a new structure in the river, how does that affect the flood levels downstream? So we're going through that permitting process, and we're making a lot of people frustrated because we're trying to get them to do it in a quarter of the time they usually do. But we have an awesome team, and the external agencies like the DNR actually have some really awesome people that work for them, and they've been a huge help for us getting this in place. So right now we're working on all the soft stuff like the contracts and the permits, and then our intent is to be constructing the dock walls where the ferry will land here pretty soon. So we're looking at shifting under the existing bridge, so the ferry will land just south of the marina by the Tiki Bar on the Iowa side, and then at the big sand pit beneficial use site on the Wisconsin side. It'll go underneath and through what you'd call the work zone, but it's going to stay open as the navigation channel. So regular users will be able to go through there, and our ferry will go through there. Yep. Yeah.
I understand that all the pilings have been driven. Could you talk a little bit about the decision to take down the old bridge for safety purposes of construction?
Right, yeah. So we actually haven't finished all the piling. We have to construct those temporary shoring towers on the Wisconsin side for the part that reaches from Pier 2 out to Pier 3. And to construct temporary shoring towers in 120 feet of sand, you can't just put them on top of mats like we can on the Iowa side. So they have to drive piling all the way down to bedrock. And we started doing that, and that's when we experienced the last movement of the existing bridge. And so at that point, we had already rebuilt part of the bridge, and we had analyzed it multiple times to develop a finite element model, or just a computer model of the bridge. And we got to a point where we couldn't push that model any further and safely continue construction. So we had to stop construction, and we have to remove the structure of the existing bridge before we can continue driving those piling. Yep. Yep.
Is there any chance when you're taking the old bridge down, the way that pier shifted on the old bridge to the north,
Mm-hmm.
is there any concern about it toppling into Pier 2 of the new bridge?
So there's enough separation that we're not concerned with that, and with the superstructure removed from the pier, we don't anticipate enough movement out of that to cause any concern for safety. So I guess the short answer is no, we don't think it'll have any impact. Yeah.
That would be all.
Yes, it would. Right into the brand new pier. So
So when you're taking the old bridge down, will it be somewhat secured to the south so it doesn't go that way, or is there any?
when we're taking the superstructure down, the truss,
Yeah.
so they're taking the truss down from, now I gotta get back to, come on. So they'll be taking the truss down starting at the western part of the center span and going towards the Wisconsin side. They'll take that entire section down with explosives. And when they do that, there's a lot of engineering that goes into that demolition plan. And if you've ever seen an implosion of a bridge structure, it's designed to go straight down. And of course, there are examples of that going wrong on the internet that you can find, but the intent is always that the structure will fall straight down into the river, and then the structure will be picked up out of the river by equipment on barges and taken over to the land and disposed of. The truss on the Iowa side will be taken apart in panels. So they'll have cranes on barges and they'll carefully remove it piece by piece because you're extending over a railroad and a roadway and you have houses nearby, so you can't use explosives on that part of the bridge. Yeah. It'd be,
Will the public be informed when they're blowing that up?
oh yeah. Everybody will know.
Before or after?
Definitely during. Yeah. But no, good question, Bruce.
Will it be a big part?
What happens to the piers then, the old piers?
So those will probably stay in place for a little bit. They want to get back to driving those piling as fast as they can because that's on the critical path. Eventually they'll take equipment and break the concrete down. They may use some explosives to blow the concrete up, but I think a lot of it will just be hammering the concrete and blowing some of it up, taking the pieces out. Yep. And they'll take the dolphins too, so the dolphins come out at the end of the project. Yeah, Bruce.
What's the schedule for the Lansing side of the new bridge in terms of the pieces of steel that'll be going in?
So we're looking at the steel is going to start showing up on site next week, and the contractor will be putting it on barges. And then it'll take a while to get ready, but I think the week of the 29th is when they're looking to start setting the first pieces of steel on the Iowa side. So it's coming up pretty quick.
So
And then
how is it going to get here?
it comes from Gary, Indiana on a truck.
Oh, okay.
And they'll deliver some of it to the Wisconsin side and put it on barges, and then some of it comes to the Iowa side, the part that composes the Iowa side of the truss. Yep. It's going to be tight though. The roads on the Iowa side are very curvy and narrow, and so it'll be tough for the contractor, but they'll figure it out.
Be posting on the internet some kind of like, hey, it's a day away, or any, because I don't know, some of us are going to want to stand around and watch.
Oh, for the new steel?
Yeah.
Yeah, we can definitely do that.
Yeah.
Give some sort of schedule when we get closer to actually setting that. Yeah, it's a good idea.
Yeah.
How much work can you do on that part of the bridge before the old bridge has to come down
So they
for you to continue?
on the Iowa side, they can build that entire piece out over the river, and so they'll actually be working on setting that up before they take the Iowa section of the bridge, the old bridge, down. And so you'll have two parts set up side by side, and then they'll start working on taking the existing bridge down piece by piece.
There'll
So-
actually be a time when the new bridge and the old bridge are both cantilevered out over the river.
Yeah, it'll be a good photo op.
Bridge, will that be open?
The middle part will be missing. Yeah.
It won't be open?
Yep. It won't be open.
Okay.
Maybe you take the Wisconsin side down first or the Iowa side after the middle is out.
Wisconsin's coming down
Yep.
at the same time.
So they'll blow all the way from the center section all the way across Wisconsin, including the approach bridge, mostly.
How many days or will that take?
The explosion will be instantaneous. It'll just
Yeah, no, but
one big boom, and then taking all the metal out. That'll be about a month-long process. So it'll take quite a while. They'll start in the river near the navigation channel and work their way over to the Wisconsin side.
So not only the center section, but all the rest of the bridge on the Wisconsin side will also be blown apart?
Yep.
How close can we get our boats to that?
Not very close. It'll be the middle of December, so I don't know if there'll be ice out there or not. But we'll have some help patrolling the river and making sure people don't get too close.
Is October 15th still the target for the demolition plan approval?
That's the target for the start of demolition, and so it gets really confusing because we call it demolition, but all the contractor's doing is removing some of the steel grate deck from the bridge. They're reducing the weight that's out there. So they'll take the steel grate off first and some of the steel beams underneath, and then it'll be ready to blow up after all those different members are removed.
But October 15th is still the target date to close it.
That's the target, as long as everything goes just to plan.
What percentage of the weight is in the floor of the whole bridge?
I guess I wouldn't say a sizable amount of weight, but Travis, do you have any ballpark?
I'm gonna say 20%. It's not so much the weight as it is the stiffness and strength. They want to be able to tear this thing apart when it's dropped, right? So the floor system holds both truss lines together, and that will be all cut free up in the air, and it'll be very wiggly, still stable, and they'll make pre-cuts in a whole bunch of members so that when you drop it, it's in 2-panel pieces. When they torch off the explosion, explosives will cut all those members, they'll drop in the river, and start grabbing and pulling out the crane. But if you don't have your floor system off, then that would be down in the mud, and it'd be a real problem.
How do the steel workers cut that? Are they tied in with like a mountain climber sort of thing?
They'll be working off of, on the deck, you'll be working right on the deck.
Yeah.
Yep.
Yeah, they'll have fall protection.
Yeah,
So-
they work off like barge, like a crane.
Some will be off barges, some will be barges with man baskets, or barge, crane on a barge with man basket to make the cuts, the high cuts, and then they'll also be working off the 135 lifts and barges off the water. So there's gonna be a lot of activity going on out here.
Yep.
And it'll be very visible as opposed to something inside of a forum.
Yep. Or deep underground.
Underground.
Is there
Yep.
a whole different subcontract tearing the bridge apart and picking it out of the river? Or does Kramer do that?
Kramer.
It's all the same contract. Yep. Yeah, Bruce.
I was just gonna say that, if you guys can pull all this off, I think you all ought to get a bonus.
Well, thank you, Bruce. It's very against Iowa code, but
Where's the comment
appreciate
jar?
that. Yeah.
Pay tax on that too?
Probably, yeah. It would be taxable income. Yeah.
I have one question.
Yeah.
Would there be a time frame that part or all of the Blackhawk Bridge could be walked on and we could say our slow death and dying prayers to it?
We've talked about this. There's a lot of liability issues with letting people
I understand the liability, yes.
walk on it, but primarily it's where would anybody park? And then you have to provide
Park
access
somewhere
for,
and walk up and walk back and stuff
Yeah.
like that.
and you'd have to provide access for those with mobility issues and all these different factors. But
Anyway,
it was a cool idea. I really liked it.
Just do it at night.
Yeah.
okay.
Somebody shut the camera off.
Yeah.
We'll meet you all there.
You had your chance the last 2 nights.
Yeah, I did. Anyway, the question
Yeah.
has been asked and you hit it.
But I think we do want to put together a last drive across the bridge.
Okay.
So however the city wants to set that up and determine a set of people and vehicles to go across, we could certainly accommodate that.
Couple of hay rides.
Maybe.
Anyway,
Yep.
thank you.
Yeah, no problem. Well, we're getting close to 6 here. Any other questions? You've had some good ones tonight. All right, I better check to see if
It's not out there.
it's not out there? Okay.
There was a breakdown of communication.
That's all right. I should have double checked with Dale today. We were going to bring in this massive wooden joint that Kramer built to show us how tight these access holes were. So they actually built that to scale from what one of the joints on the new bridge is going to be. And then to put these bolts together, somebody actually you have these same holes on the bottom, and somebody has to climb up in those holes to tighten the bolts. Unless, some of them, not all of them, but
Well, they get bonuses.
hopefully, yeah.
I managed to fit through one of those, but it was tight.
Yeah.
And so there was a change order to make a larger man size XL.
For somebody wearing a life vest. Yeah. But that, anyway, maybe we'll get that here another day. Travis has
Next month.
something really cool up on the wall.
So if you keep back up a couple of clicks to where we have that cantilever picture. That one. So over here we got the west abutment. That's the whole down. We have the two shoring towers. I don't know if this thing is recording or not, but
Oh, you need to turn it on, yeah. The bottom button, just hold it. And then the blue lights.
okay.
Blue lights on, so.
There you go. It's on.
So
Thank you.
if you can take that picture and superimpose it up here, you'll see that we've got, excuse me, we've got our west abutment and Pier 1. So here's your L knot. So that's where, or L1, this is where your first shoring tower is sitting in the alley. And then the second shoring tower is at 2.75, which is just right here before L3. That's sitting on 2nd Street. And then the railroad and the pier goes in between here. And this is just, it's not quite all of the floor system yet, as I still need to put the stringers and the stringer bracing in. But this is the first 4 bays with the floor beams, all the gussets, all the lateral bracing, and then there'll be 5 lines of stringers that go in here to be put together. And then I'll start putting on the upper chord and then the verticals and diagonals to fill out the truss. And we'll be switching over to walnut wood for the compression members to help us illustrate what this looks like under dead load. So this is really small and finicky to make these little strips to put it together. But I'll set it down here on the table so you can take a look at it. You will see these same exact pieces start to show up out here on the job site and be erected. And the erection will be a little different than this, obviously with the shoring towers and sequentially being built. But this should give you a really good idea of what this thing is going to look like. And of course, I did not make the actual section shapes. These are just rectangular. But this is the first 4 of 25 bays, to give you an idea. And this is all to scale.
Yeah, 1 to 20?
One inch equals 5 feet.
1 inch equals 5.
So there's about 10 inches in between each one of these.
Cool. All right. Well, that's all we got for you this month. I appreciate you all coming out, and we'll be back at it next month.
Thank you.
No,
I got to interrupt. I got
Oh,
a little
go for it.
advertising. You reminded me. We have a couple programs coming up. The rivet ladies that worked on airplanes in Iowa during the war. These 2 are putting on a program talking about Egypt. And if you want to go visit, I'm sure they could tell you what you might want to see and so forth. And bring your kids. They got some goodies planned. We will be serving some snacks. Another one.
Souvenirs.
And yeah, their suitcase came full of souvenirs. And the
So that's
other
next
one we
Thursday.
have, if any of you remember Robert Taunt, he's a river historian, lives in La Crosse, and he talks about the War Eagle, but now he's talking about all the famous people who rode the river and steamboats. These programs are here at the library. I'll just leave this out. Take a picture so you don't forget the times and the dates. So thank you for coming. We'll see you, at one of the programs and next month.